Yes, dear students, let's see the 16th question. The given 16th question, if you observe that X2O4 liquid is converted into 2 moles of XO2 gas. So for this equation, what they gave, dear students, the internal energy change, delta U value they gave, that is 2.1 kilocalories. And the delta S value they gave, the delta S is equals to 20 calories. 20 calories per Kelvin inverse. Okay, this 20 calories means you have to convert into kilocalories. Then the 20 into 10 to the power of minus 3 kilocalories to Kelvin inverse. Okay, students, and the temperature is equals to 300 Kelvin's temperature they give. So for this equation, for this relation, we have to find out delta G value. We have to find out. Okay, students. So the delta G we need to find out. What is delta G and how to find out delta G? We know very well, dear students. The delta G is equals to delta H minus T delta S. This is the formula to find out the delta G. Okay, but in the given question, delta H value not given directly. So the delta H value we have to find out by using internal energy. So what is the relation between delta H and delta U? We know very well, dear students, that delta H is equals to delta U plus delta n RT, delta n RT. So I got by using already delta U value 2.1 kilocalories they gave, and delta n value we need to find out for the above equation. So the delta n value is equals to the number of moles of gaseous products, the number of moles of gaseous state products minus the number of moles of gaseous state reactants. So the product has 2 moles of gases are present, the reactants 0, means 2 minus 0 is equals to 2, delta n is equals to 2k, and R value in terms of calories we need to write. R is nothing but universal gas constant, is approximately 1.98 calories, is nothing but 2 calories. The 2 calories is nothing but 2 into 10 to the power of minus 3 kilocalories. Into 10 to the power of minus 3 kilocalories, and the temperature is equals to 300 kelvins. So we know all the values, then we have to find out delta H. So the delta H is equals to, delta U value is 2.1 kilocalories plus delta N value is 2 into R value is equals to 2 into 10 to the power of minus 3 into temperature is equals to 300 kelvins temperature. Is on simplification will get delta H value. Is on simplification will get delta H value is equals to 3.3 kilocalories. 3.3 kilocalories. Okay, students. So the delta H value we know that. Now we have to find out delta G. So the delta G is equals to Gibbs free energy change is equals to delta H, means 3.3 minus temperature is equals to 300 kelvins into delta S value. Already we know that the delta S value is equals to 20 into 10 to the power of minus 3. 20 into 10 to the power of minus 3 is on simplification will get 3.3 minus this is on simplification is nothing but 6.0. 6.0 is equals to minus 2.7 kilocalories. Okay, students. So this is about delta G value. So here delta G value we need to find out, means delta S we know that, temperature we know that, but delta H we don't know. So how we are find out delta H value, dear students? By using internal energy. So we know the relation between delta H and delta U. The delta H is equals to delta U plus delta N RT. Delta N is equals to number of moles of gaseous products minus number of moles of gaseous state reactant. Then the delta N2 came, and R universal gas constant in terms of calories is equals to 2. The 2 calories is nothing but 2 into 10 to the power of minus 3 kilocalories. Okay, and temperature is equals to 300 kelvins. Okay, students, this is about a 16th question. So the answer is a B option is correct. Okay, let's go for 17th question, dear students. 17th question. What is the given 17th question, dear students? The enthalpy of fusion of water. What is the fusion? Enthalpy of fusion of water means H2O ice is converted into H2O liquid. The required amount temperature is known as enthalpy of fusion. Delta HF is known as enthalpy of fusion of water is equals to 1.435 kilo calories per mole they gave. Okay students, this is about enthalpy of fusion of water. Means enthalpy of fusion means the amount of temperature required uh, 1 mole of ice converted into liquid is known as enthalpy of fusion. Okay, and the molar entropy change we need to find out, and melting point temperature, this that ice will be melted into liquid state at certain temperature is known as melting point temperature. Then the melting point temperature is equals to 0 degrees centigrade. Then this is T is equals to melting point temperature is equals to 0 degrees centigrade is equals to 273 kelvins. Now for this transformation, phase transformation, the entropy change, the molar entropy change, delta S is equals to delta H F by T. So the delta H value we know that is nothing but 1. So if you observe that the options, all answers are they given in calories, but delta HF value we know that in kilocalories is there. So we have to change into the calories, means 1.435 into 10 to the power of 3 calories per mole. Okay students, now the delta HF value is equals to 1.435 into 10 to the power of 3 divided by the temperature is equals to 273 kelvins. Is on simplification we'll get 5.26 calories per mole Kelvin. So the answer is 5.26. 5.26 means third option is correct. Okay students, let's go for 18th question dear students. What is the 18th question dear student? The standard enthalpy of vaporization of for water is at 100 degrees centigrade is equals to, what is enthalpy of vaporization? Enthalpy of vaporization means the water liquid is converted into water vapors. Water vapors means in convert into gaseous state, then the amount of heat required for water liquid is converted into in its vapor state is known as a enthalpy of vaporization. That value how much they gave dear students? 40.66 kilojoules. 40.66 kilojoules per mole they gave. Okay students, now and for this conversion, that liquid is converted into vapor state, then it is called as boiling point temperature. That boiling point temperature, the T is equals to 100 degrees Celsius. 100 degrees Celsius is nothing but 100 plus 273 is equals to 373 kelvins. Okay, so the temperature is 373 kelvins. Then the internal energy of vaporization of water at 100 degrees centigrade. So the delta, what we have to find out here students, delta E value we need to find out. Internal energy delta E value we need to find out, and we know that delta H, so already delta H value they gave, and the delta H is equals to delta E plus delta N into RT, delta N into RT. Okay students, now for this we know delta H value we know that 40.66 kilojoules per mole, and delta E value we know to find out, and delta N is equals to, this is in gaseous state, means 1 minus 0 is equals to 1, and R value in joules 8.314 joule per mole Kelvin. Okay, is nothing but 8.314 into 10 to the power of minus 3 kilojoules, because the options they given in kilojoules, that's why that R value I converted into kilojoules. 10 to the power of minus 3 kilojoules per mole kelvins. Okay, R value we know that, and temperature is equals to 373 Kelvin. Just you have to substitute in the above formula, then we'll get internal energy. So the delta E is equals to delta H minus delta N RT, delta N RT. The delta H value is equals to how much, dear students? 40.66 minus of delta N value 1 into R value 8.314 into 10 to the power of minus 3 into temperature is equals to 373 kelvins temperature. First you have to multiply this and you have to subtract, then we'll get is on simplification we'll get 37.56 kilojoule per mole, kilojoule per mole. This is about internal energy change. So the internal energy change we are find out. So enthalpy of vaporization, delta H value they gave and delta E value we need to find out. So the delta H and delta E relation is what, dear students? The delta H is equals to delta E plus delta N into RT. Delta N is nothing but is the difference between the number of moles of gaseous products and number of moles of gaseous state reactants. Okay, then the delta N 1 came and R value we know that universal gas constant temperature. Just we are find out delta E value. Internal energy change we are find out is nothing but plus 37.56. 37.56. A option is correct. Okay, students, let's go for 19th question. Okay, students, 19th question. If you observe that, what is 19th question? Is very easy. Just read the question properly and try to understand what are the given values and what is the formula and how to solve. So like the way if you are thinking, then we can solve easily physical chemistry questions. Okay, if the enthalpy change for the transformation of liquid into liquid water into steam, liquid water into steam means H2O is in liquid state is converted into H2O water vapors or is converted into gaseous state is nothing but during this phase transformation the amount of heat required is nothing but enthalpy of vaporization. So how much they gave, dear students, is equals to 30 kilojoules, 30 kilojoules per mole they give. Okay, at 25 degrees centigrade temperature and T is equals to 27 degrees. 27 degrees is nothing but 27 plus 273 is equals to 300 kelvins. So the temperature for this phase transformation, the temperature is equals to 300 kelvins. The temperature is equals to 300 kelvins. Now 300 kelvins. Okay, students, 300 kelvins temperature is present. Entropy change for this phase transformation would be delta S value we have to find out. Okay, the delta S for this phase transformation is equals to delta S is equals to, already we know that the formula is equals to delta H vaporization by temperature. So the temperature, how much they gave, dear students? Delta H is equals to 30. So the options, if you observe that joules they gave, but the value delta H is in kilojoules. That's why 30 into 10 to the power of 3 joule per mole. Okay, divided by 300 is on simplification. We'll get 100. Is on simplification we'll get 100 joule per mole kelvins, 100 joule per mole kelvins. Okay, students, so the answer is D option. D option is correct. And let's see the 20th question, dear students. 20th question, which of the following is a correct option for the free expansion of an ideal gas under adiabatic process? Okay, under adiabatic process. Adiabatic process, in adiabatic process, Q is equals to 0. The amount of heat is 0 and delta T is also is equals to 0. So which of the following is correct except for free expansion of ideal gas and free expansion. So free expansion process, the P external pressure is equals to 0, hence work is equals to 0. That's why the correct relation is Q is equals to 0 and delta T is equals to 0 and work W also is equals to 0. So the correct answer is C option. C is correct. Okay, students. Let's see the 21 question, dear students. What is the 21 question? In a closed insulated container, a liquid is stirred with a pedal to increase the temperature. Which of the following is true? They said. So closed insulated container. Insulated container. So the insulated container means Q is equals to 0. Okay, students. So the insulated container, the amount of heat is constant. The amount of heat is a constant. Amount of heat is constant. Okay, students, the amount of heat is a constant. That's why Q is equals to 0. Now, according to first law of thermodynamics, okay, students, according to first law of thermodynamics, delta E, the internal energy change is equals to Q plus W, and Q is equals to 0 means the delta E is equals to W. Means the internal energy change is equals to work, and the closed insulated container is stirred with pedals means increasing the temperature. If the temperature increases, work done on the system, W increases the internal energy, delta E value increases, will be increases. So the correct relation is equals to the delta E is equals to W not equal to 0, and Q is equals to 0, This is the correct relation, dear students. Okay, so the answer is delta E is equals to W not equal to 0, but Q is equals to 0 because of the insulated closed container. Then the amount of heat is constant, then Q is equals to constant, 0. So the correct answer is 21 is equals to A. Okay, students, let's go for 22nd question. Let's go for 22nd question, dear students. The 22nd question, what is the 22nd question, dear students? If you observe that 22nd question, when 1 mole of gas is heated at constant volume is raised temperature from 298 to 300 kelvins, the heat supplied to the gas is equals to 500 joules. Then which of the following statement is correct, they said. Okay, so constant volume is constant. Okay, volume is a constant, V is constant, volume constant. Then delta V is equals to 0, then work W is equals to 0, students. Why work is 0? Because W is equals to minus P delta V. If delta V is equals to 0 means minus P into 0 is equals to 0. So under constant volume, delta V is 0, then the work is 0. Then the work is 0. Then which statement is correct, they asked. So, according to, you have to take first law of thermodynamics. According to first law of thermodynamics, according to first law, the delta E, the change in the internal energy is equals to Q plus W, but W is equals to 0 they gave, the delta E is equals to Q, and how much amount of heat they supplied to the system, dear students, but Q is equals to 500 joules. The Q is equals to 500 joules. Then delta E is equals to 500 joules. The delta E is equals to 500 joules. Internal energy change is equals to 500 joules. So the Q is equals to, delta E is equals to 500. Okay. So the answer is Q is equals to delta E is equals to 500 joules and work is 0. So the correct answer is B option. B option is correct. Okay, students. And let's see the 23rd question, dear students. 23rd question. What is the 23rd question? Identify the correct statement regarding entropy. Entropy they asked. Entropy means S. Okay. Entropy. Entropy means, what is the meaning of entropy, dear students? Entropy means the randomness of a system is known as entropy. So the all naturally occurring process or in spontaneous process, entropy will be increases. The entropy of the system, sorry, entropy of the universe always increases, because the naturally occurring process all are exist in universe only. Then the entropy of the system, entropy of the universe always positive. So regarding these statements, which statement is correct, we need to identify. Okay, what is third law of thermodynamics? The third law of thermodynamics. The third law of thermodynamics is nothing but at absolute zero, absolute temperature. Absolute temperature is nothing but 0 kelvins. Okay, student, 0 kelvins is nothing but minus 273 degrees Celsius. At absolute temperature, a perfect crystal, a perfect crystalline substance or crystalline substance, a perfect crystalline substance, a perfect crystalline substance, entropy is 0. Entropy is 0, is known as a third law of thermodynamics. So which statement is correct, dear students? Third statement, let's see, the absolute 0, the temperature, at absolute temperature or absolute 0 of temperature, the entropy of a perfect crystalline substance is considered to be 0, is considered to be 0. But to maintaining that absolute temperature is very, very difficult. That's why in nature, perfect crystal means entropy is equals to 0, like perfect crystals are not existing. That's why crystal defects we are studying in solid state. Okay, students, this is about a third law of thermodynamics. And let's go for next question, dear students. 24th question, dear students. So the standard entropies, S values they gave, the standard entropies of x2, y2 and xy3 they gave respectively for the given equation. The delta H value they gave, and at equilibrium state the temperature should be, we need to find out. Okay, so for this, what is the relation? First we have to find out at equilibrium state. First at equilibrium state, delta G is equals to 0. Okay, the change in free energy is equals to 0. Then delta G is equals to delta H minus T delta S. Now delta G is equals to 0 means delta H minus T delta S is equals to 0 at equilibrium state. Okay, from this the temperature is equals to delta H by delta S. So that equilibrium temperature, this temperature is known as equilibrium temperature. Equilibrium temperature, how to find out the equilibrium temperature? T is equals to delta H by delta S. Okay, students. So for this given question already delta H value we know that. And the equation, if you observe that half mole X2 plus 3 by 2 moles of Y2 is converted into XY3. 1 mole of XY3, and delta H is equals to minus 30 kilojoules they give. Minus 30 kilojoules. Okay. Now we have to find out minus 30 kilojoules is nothing but minus 30 into 10 to the power of 3 joules. Minus 30 into 10 to the power of 3 joules. Okay, students. So delta H value we know that, but delta S value how to find out? The delta S value is equals to the sigma entropy of products minus the sigma entropy of reactants. Entropy of reactants we need to find out. So the entropy of product means the entropy of XY3 minus the entropy of 1 by 2 x2 plus 3 by 2 entropy of y2. Okay, already x2 and y2 xy3 entropies they gave. So what is the entropy of x2 they gave 60, and y2 they gave 40, and xy3 they gave 50. So the 50 joules per Kelvin. 50 minus of 1 by 2 x2 value is 60 plus 3 by 2 y2 value is 40. Y2 value is 40. Okay, students. Now is nothing but 50 minus 30 plus 60, 90. Okay, then 50 minus 90 is equals to minus 40 joules per Kelvin. Okay, so the delta S value we know that, and delta H value also we know that. Then the temperature is equals to delta H by delta S is nothing but minus 30 into 10 to the power of 3 divided by minus 40. Then minus will cancel, and is on simplification will get 750 kelvins. So at 750 kelvins exist at equilibrium state at T is equals to 750, then delta G is equals to 0, exist equilibrium state, and that above the temperature is above 750, delta G is equals to negative, and below the temperature, if delta G is negative means spontaneous, and below that the temperature 750 below, the delta G is equals to positive will comes, and it is a non-spontaneous. So these three conditions related questions also earlier in the last video we explained. Okay, students. So but in this what they asked, what is the equilibrium temperature, only they asked. The equilibrium temperature T is equals to delta H by delta S. Delta S value we are find out in the above values. Based on the above values, we are find out delta S is equals to sigma entropy of products minus sigma entropy of reactants. Then the delta S of the above reaction is equals to minus 40 joule per Kelvin came. Okay, then the temperature is equals to 750 kelvins. Let's go for 25th question, dear students. 25th question. What is the 25th question? It's very easy. The 25th question is consider the entropy S, the thermodynamic parameter, certain spontaneous process. The spontaneous process means these are always always irreversible. Always a irreversible process. So the irreversible process, delta G is equals to negative, and the entropy delta S is equals to positive, always a positive. The delta S for universally occurring process, all are a spontaneous process, then the delta S of system plus delta S change of the entropy of the surroundings is equals to the delta S of universe is always positive, is always positive for spontaneous process, for spontaneous process. Okay students, so it's very important. So the answer is first option is correct. Okay, let's go for 26th question, dear students. What is the given 26th question? The given 26th question, if you observe that, what is the relation between x and y, they are asked. Okay, now here if you observe the combustion process, the enthalpy of combustion. What is combustion process? During the combustion means oxidation only. So the combustion process are always combustion process are always exothermic, always exothermic, and delta H is equals to negative only, always exothermic, and delta H value is always a negative sign only. So for this equation, the enthalpy of this equation means combustion of methane. On partial combustion of methane, we are producing methyl alcohol, and delta H is negative, K means it is also exothermic process and exothermic, but individually the enthalpy of combustion of CH4 and enthalpy of combustion of methyl alcohol, they gave x and y respectively, and we have to find out the relation between x and y. X and y relation we need to find out, whether x value is more or y value is more, we have to find out. Okay students, now let's see that. Yes, first combustion of methane, you write CH4, methane is on combustion, is on complete combustion, we are producing carbon dioxide and the water, and delta H, let it be, you have to take delta H1 is equals to x, they gave is minus x, because is the negative sign, then delta H1 is equals to minus x. Okay, and how many moles of oxygen utilizing this? 2 and 2, for 2 moles of oxygen is enough. Okay, let it be first equation. Now the second methyl alcohol combustion you have to take. CH3OH is on combustion to produce, is on combustion to produce carbon dioxide plus water. Okay, carbon dioxide and water. Now here 3 oxygen atoms are present. Now that CH3OH, then you have to use 3 by 2 moles, then 4 hydrogens means total 2. So here 2 plus 2, 4 are there, here 1, and 3 by 2 means 3 plus 1, 4 will comes, like 3 by 2 moles of water is required. In this process the delta H is equals to, it is also exothermic, minus y. The reverse equation you have to write, then the reverse is CO2, formation of methyl alcohol, right? CO2 combined with 2 moles of water and to produce CH3OH plus 3 by 2 moles of O2. It is exothermic, then the reverse is endothermic. Then the delta H2 is equals to plus Y. Okay. Now let's see that just you have to add 1 and 2 equations. or 1 minus 2. CH4 1 plus 2 you have to do. That 1 plus 2 you are doing means this CO2 and this CO2 will cancel, and 2H2O and 2H2O will cancel. Then CH4 plus 2O2 is converted into CH3OH plus 3 by 2 moles of O2, and this for this delta H is equals to delta H1 plus delta H2. Okay, and this nothing but 3 by 2 is coming on the left side. Then CH4 plus 2O2 minus 3 by 2 O2 is nothing but the LCM is 2. 4 minus 3 by 2 O2 is nothing but half O2 will comes. CH3OH, and this delta H is equals to delta H1 is exothermic. Sorry, this is exothermic process. The resultant value, this delta H is exothermic means the delta minus of delta H1 plus delta H2 will comes. So the resultant value is a negative sign will comes. So he is nothing but, sorry dear student, delta H1 plus delta H2, and this value is y minus x. Y minus x is nothing but CH4 plus half O2 is converted into CH3OH, comma delta H is equals to y minus x came, but it is exothermic process. It is exothermic. Exothermic means delta H is equals to negative. The delta H is negative means the delta H value what we got is, students, y minus x is equals to negative sign. That resultant value is negative sign means what it is, that y x value should be more. Then for example, y is equals to some 50, x is equals to 100 k means 50 minus 100 minus 50 will come. The resultant value is negative. Then the x value should be more than y. The x value should be more than y. Then only the delta H will becomes a negative sign will comes, and it is exothermic. They given very clearly. That's why x is more than y. So this x value is more than y will comes. Okay. So the relation is A. Okay, students. Just the both combustion of methane and combustion of methyl alcohol separately you have to write, and you have to try to get that equation combustion of methane converted into methyl alcohol. Try to get that equation we are getting from 1 and 2. Then the delta H is equals to delta H1 plus delta H2. Then y minus x came. That y minus x value is, resultant value is negative. Then when it will becomes negative, dear students, x is more than y. So the relation is A option. Okay, students, and let's go for next question, 27th question. 27th question, dear students, it is also relation only. So from the two equations we have to find out the formation of SO2 value. SO2 formation we have to find out. Okay, let take that given equations. S plus 3 by 2 moles of O2 is converted into SO3, and it released energy is 2x kilocalories. Okay, and the second one is if you are taking that second reverse equation means SO2 formation we want. SO2 plus half O2 is converted into SO3. In this process the released energy is Y. Let it be take 1. You have to this convert the reverse equation. You have to write SO3 plus SO3 is converted into SO2 plus half O2. SO2 plus half O2, and this plus Y is converted into minus Y. This is second equation. Let you have to add 1 plus 2 will get this SO3 and SO3 will cancel. There 3 by 2 moles of O2 is there. 1 by 2 moles of O2 is nothing but S plus O2 S plus O2 is converted into SO2 plus 2x minus y. So during the formation of SO2, how much amount of heat is formed, dear students? 2x plus 2x minus y is forming. So the answer is D option. Okay. And 28th question, if you observe that, what are the signs of delta H, delta S and delta G signs we need to find out. It is nothing but octane, combustion of octane, C8, H18, okay, minus plus 25 moles of O2 is produced to 16 moles of carbon dioxide gas and 18 moles of H2O gas. H2O gas. Okay. Now these all are in gaseous state only. Now it is combustion process. Is nothing but is a combustion reaction. Okay, combustion reactions, delta H is equals to negative because of exothermic. Okay, now we know that delta H sign, we know that it is, what is the delta H sign, dear students? Negative, we find out. Now entropy, so the entropy will be increases. So the entropy, if you observe that the gaseous reactants, gaseous state reactants, how many are there? 2 moles and here 25. Total gaseous state reactants is equals to 25 plus 2 is equals to 27 is there, and gaseous state products, gaseous state products, how many are present here, students? 16 plus 18, 16 plus 18. Okay, how much? 16 plus 18 is nothing but 34 moles are present. So 34 gaseous moles are present, means entropy will be increases. Entropy increases. That's why the delta S is equals to positive. Okay. Now delta G is equals to delta H minus T into delta S. Okay. Then it is already, we know that it is negative sign and it is positive, and if minus symbol is there, we know that plus into minus or minus into plus is equals to minus only. Then it is also minus value, then the delta G also negative sign will comes. Okay. So the correct relation is delta H is equals to negative and delta S is equals to positive. Why delta S positive, ma? So the more gaseous moles products are present when compared to gaseous moles of reactants, the total number of gaseous state products are more when compared to gaseous state reactants. Okay, that's why entropy will be increases. So the entropy of gases are more than liquids and then solids, so that number of gaseous state products are increases when compared to reactant. That's why entropy is increasing. The entropy change increasing means delta S is positive and the delta G is negative. So the answer is plus minus plus minus. D option is correct. Okay, students. And let go for 29th question, dear students. 29th question. So 29th question, if you observe that a system is changing from A to B, a system is converting, A is converting into B. Okay. So in a closed system, A is converted into B in reversible process. In reversible process, again B is converted into A in irreversible process. Irreversible process is nothing but closed system. It is a closed system. So in this closed system, what is the change in the net change in the internal energy? In closed system, the net change of internal energy delta E is equals to 0. Delta E is equals to 0. The reversible path and it is irreversible path. Why the internal energy change in closed system is 0? Because of it is a in closed system. In closed system means the total in a circular path. It is a circular path means again it start where it is started, again it is coming to the same path. Again is coming to the same path because the internal energy, because delta E is independent of path. Okay, it is a path independent. It is a state function. Internal energy change is a state function, is independent of path. That's why again where it is started, again it is coming to the same point. That's why net internal energy change is 0. Net internal energy change is 0. Okay, students. So the 29th question answer is C. Okay, and 30th question. Let's see, dear students, 30th question. What is 30th question? So they given work, PV work they gave, pressure and volume work. The pressure and volume work is taking place in 3 paths. A is converted into B in 3 paths. Okay, and it is first path 1, it is 2, and it is 3. So that work is a path function. Work is a path function. That work W is equals to P into delta V. P into delta V, change in the volume. If that P, the area of P into V, P into delta V or P into V increases, the area of P into V increases, the work will be increases. Work increases. So the P into V area order. The P into V area order, which is area is more, dear students. If you observe that this third one occupied area is more. So that 3 is more than 2 and then 1. That's why that work maximum work order, work which has a maximum work order, is W3 is more than W2 and then W1. Okay, students. So the answer is B option is correct. B option is correct. Okay, let's go for 31 question, dear students. The 31 question, 10 moles of ideal gas is expanded isothermally during the expansion, isothermal expansion. Isothermal expansion. Isothermal expansion is nothing but work done by the system. So that work done by the system in isothermal reversible expansion, that is equal to isothermal expansion, reversible expansion. The work is nothing but work done by the system is nothing but the negative sign minus 2.303. So here the pressures they given, initial pressure and final pressure. Okay, so minus 2.303 RT, sorry, minus 2.303 nRT into log P1 by P2. Log P1 by P2. Then work will comes. Okay, the W value will comes. Is nothing but work done by the system. Now this work, during this work is carried out 100 meters height. How much amount, maximum amount, how much it will takes? That work is nothing but movement of the object against to the force. Okay, movement of the object against to the force. That how much amount is moving? up to 100 meters that we need to find out finally. First we have to find out the work. So the W is equals to, work is equals to minus 2.303 into N, 10 moles they gave. Okay, and R value in joules 8.314, and temperature is equals to 300 kelvins temperature, and log P1, the initial pressure is 10 atmospheres, final pressure is 1 atmosphere, that log 10 value is 1, log 10 is equals to 1, then is on simplification, we'll get minus 2.303 into 10 into 8.314 into 300, is on simplification we'll get minus 57,441 joules. This is the work. Now this work will carries how much amount of weight is moved to the 100 meters height. So we know that work is equals to minus mgh. M is nothing but mass. M is nothing but mass. We have to find out. And G is nothing but gravitational force, 9.8 meter per second square. Meter per second square. And height is equals to 100 meters. 100 meters they gave. Okay. Now it is already in joules. Already we know that 1 joule is equals to kg meter square per second square. Okay students, then the mass will comes in kgs. Mass is equals to how many kgs? We'll find out. So that work is equals to minus 57,441 is equals to minus m into g value 9.8 into height 100 meters. Then m is equals to, that minus will cancel, that m is equals to 57,441 divided by 9.8 into 100 is on simplification. We'll get the amount, how much amount mass will comes, dear students, that is equals to 58.55 kgs. 58.55 kgs of mass is moving up to 100 meters when that work will be 57,441 joules work is going on. Work done is going on by the system. The system did how much work, dear student? 57,441 joules work did by the system. Then that object, how much amount of object is moved up to 100 meters, dear students? 58.55 kgs object is moved up to 100 meters. So here work done by the system. Formula during that pressure and pressure cases, the formula is equals to minus 2.303 nRT into log P1 by P2. That work is equals to, from by using that work we have to find out the mass amount. Mass we have to find out, object mass. So in that case the formula we have to remember, dear students, W is equals to minus mgh. G is nothing but gravitational force is equals to SI units 9.8 meter per second square. Then the mass of the object will comes 58.55. Okay, so it's very important. Okay students, this is about thermodynamics, different kinds of objective questions. Okay, please subscribe my channel and like and share. Okay students, I will do more and more objective related videos. Thank you for all.